So congratulations, you made it to like the last talk of Spark Summit. Yeah, exactly. And we thought, what better way to turn your brains completely into mush than talk about sessionization at petabyte scale. But regardless, we did not plan, so we did not make this the last talk. But I'm Elliot. I'm a solutions architect at Databricks. I do a lot of work with Comcast and with other clients. And this is Fiona, an engineer at Comcast. And today we're going to be talking about the Comcast view of building sessionization, right? First with Fiona, and then I'm going to be talking about Databricks and the different work that we do with other clients around Delta and streaming.
Right. Thanks, Elliot, for the introduction. So to give people a little bit background, in case you don't know what Comcast is, we are a technology company that provide TV, internet, phone, and home security services to our customer. And like any service provider, we want to provide the best experience to our customer, and we want to do it in the individual preferences space. You may ask, okay, what does that mean? I'm a part of a team called PABS, that stands for Product Analytics and Behavior Science. And we believe that nothing speaks louder than people's actions, and the way they will listen to it is through data. We are a team of data engineers and data scientists. We create consumable insights through statistics to empower and equip our product teams to make the best decisions for our customers when it comes to product, feature, and experience design. And naturally, as a company that scale, we deal with a lot of data. Now, how much exactly are we talking about? We ingest and transform 1 billion of events per day. We query and scan petabytes of metadata and telemetry data, and to enrich as much as 1 million transactions per second. That's a lot of data that we're dealing with. It's impossible in that scale to extract information, let alone trying to help our customer build a better experience. So what do? The idea of sessionization is to group a series of events into a much manageable data chunks so that we can extract insights from. And each data chunk is what we capture in intent. That goes anywhere between a voice to tune, someone searching for content, someone trying to find an interesting video or funny things on YouTube. And since our data is highly transactional and it represents a very specific point in time, sessionization and grouping things is not as easy as counting and summing operations. While we're building this pipeline, there's a couple things that we want to keep in mind. No data engineers want to rebuild what they do. So we want to make sure that the things that we built today can sustain at least a good 5 years as the company scale that goes between all our data and all our products. The second thing is, since we have data scientists that depend on our data to build features and make decisions, it has to be reliable and robust and consistent. And our data is very time sensitive. The faster we can spot anomaly and act on it, the better experience we can provide as a company. So this has been a really long journey for us. What happened? What changed? So before this journey, we went from a batch process to now we have a streaming process. We successfully reduced an 84-job pipeline to just 3 jobs. We have reduced data latency by half. And we have also, using Checkpoint, be able to handle late data and handle failures. Now let me walk you through a little bit of our process. Our initial design is a multi-hop process, batch, not streaming. We write out data at each data points and after each stage to make data available and also to keep our cluster size and memory demand low. But did it scale? No, it did not scale. It worked successfully when we're testing in small batch of data. While we try to put through a terabyte of data through this pipeline, we have encountered AWS I/O issue when we're on write. We have tried repartitioning to keep the number of files written small, but that didn't fix the issue. So we have to find a way to make it right. The first thing that we did is to break up a once-a-day process into multiple times a day to keep the batch size small. The second thing that we did is to scale S3. By adding manual keys, we're able to group big chunks of files into smaller chunks. And after manually adding partition into S3, we're successfully able to write now. But that also introduced other problems. First is this pipeline is extremely fragile and unpredictable. Because we have to group a particular user in a particular key, there's no way for us to tell that how much data is going into each key. So there's a high data skewing issue, and we sacrifice performance. Because of that, runtime is also unpredictable. And since our pipeline is highly dependent on time and the product of the previous state, we have to increase the time latency between each state and make the data not as available as we would like it to be close to real time. The second thing is, as you can see, we're adding a lot more jobs. It makes our pipeline much more complex and much more difficult to manage. We also actually have a partition schema. Just to give you a little bit of perspective, each key will add a minimum of 240 files. And this is clearly going into a big issue because if you try to read a lot of small files, you would know that it's not performing. We also try repartitioning the data, but that's also another overhead that we have to deal with. Now, when it comes to our end users, all our data scientists are forced to use a structure like this, and it just creates more issues for more people. So we know that we can do better. This runs, but it's not scalable. So we went back to the drawing board. The first thing that we did is we moved some of our batch processes into streaming processes. With checkpoint in streaming, it takes care of all the late data issues, and it also helps us and give us a safe net for failure. I'll go into that a little bit, but this still has some limitations. We quickly realized that not all processes can be moved into streaming as easily as we thought. Our process is very highly sequential, and we use a lot of windowing functions. We have tried to move some of that into structured streaming, but that did not work well for us because we end up having to use multiple watermarks, not knowing where to anchor all those watermarks, and having to write out the data and the process halfway, pick it back up. It just becomes really complex, and we simply don't have the expertise and the people to maintain a pipeline in such scale. So we choose to keep it as batch. So our rule of thumb right now is if processes can be run independently and concurrently, they can be moved to streaming relatively easy by just changing a read and write statement. But something that is very log time dependent, that will take a little bit more investment and time. The second thing that we realized is processing time issue. We quickly realized that just throwing more nodes in your cluster is not going to solve your performance issue, especially when it's caused by an I/O bound. Without going deep into Spark and having the expertise, we cannot solve this easily. So the two key takeaway that we have with this exercise is if you have processes that can run independently, please feel free to move it into streaming because they're relatively simple. Otherwise, you may need to invest some time into it. Second thing is just increasing this cluster size that you have for these processes is not going to solve your performance issue as you would probably expect. So what we did is we moved into Delta. And Delta enabled us to do faster streaming and make our queries run more efficiently. Now, to address our I/O bound issue, what we did was we have enabled random prefixes. It has systematically replaced all the manually generated key that we had and allowed read and write to scale. It resulted in a much faster and predictable turnaround time. And to address our small file issues, we have optimized runtime from once a day to once an hour. But then the slowdown from optimize becomes more apparent Every time optimize is being run, it puts all the read and process from that certain bucket down, and we know that we can do something better about it, because then our scientists will have to be on hold when they're running predictive modeling. So thanks, we have auto-optimize to the rescue. By enabling auto-optimize, it had removed the need for us to manage optimization and eventually make the slowdown issue go away and trim down our processes even more. And Delta also enabled more efficient upstarts. Now we're able to build journey tables and build a more wholesome picture for our products and our user experience. It has been a really long journey for us. We were able to accomplish everything that we have built previously with Batch on the left side to something that we have currently on the right side. It had made our process a lot more simpler. It had reduced our data latency by half. And by enabling streaming, we don't have to worry about data duplication anymore because we always have a checkpoint to recover from. And by enabling Delta, we're able to process more data faster and more reliable. Now our engineers can focus on making data more available. Our scientists can focus on building data pipeline, knowing that the data is going to be there timely when they need it. And as a result, we're able to create solutions for our product organizations faster to address all our customer features issues and our experience issues. Now I'm going to head over to Elliot, who's going to cover it a little bit more on the technical side and give you a demo on how this actually worked for us.
Awesome. Thanks, Fiona. That's really great. Yeah, so I mean, one thing that I'll just add there is what we actually really pride ourselves on is really deep partnerships with our customers. And some of these features, like auto-optimize, we worked very, very closely with the different teams at Comcast in order to actually implement that to make sure that it worked for their use case and make sure that it worked as we're scaling up their use case, as they're scaling up their data. So it's super awesome to see all the work that Comcast has been able to do on top of Delta. So what I'm going to talk about for a couple minutes here is really the journey that I've seen a lot of our customers take from batch to streaming. Maybe some of you folks are sort of on the cutting edge in the same way that Comcast is, and you've already made the jump, right? Maybe some of you still today do majority of your processing in batch. And what I hope that you take away from at least my section is don't put off the move to streaming, but it comes with a lot of really great benefits. And I'm also going to walk through a demo. I don't have my EC2 charges on my credit card, so I can't show like the Comcast scale, but I'll show in a small way some of the new features and what this looks like to move from batch to streaming and into Delta. So when I go and I talk to customers, I ask them why do they move to streaming? They usually come to me with a couple of different types of requirements. They'll come with functional requirements. They'll say, I'm building a machine learning system with recommenders. I want that system to be able to deploy in real time, and I think that by deploying in real time, I'm going to get this amount of lift with my different ML systems. They sometimes come to us with SLAs, right? Our customers say, we're supporting a business unit as a data engineering team, and our business unit wants a certain data within a certain period of time. And then they sometimes come because this is just how the data is, right? I'm pulling data off a Kafka stream. I obviously can't do that in a batch process, so I need to use structured streaming as part of my process. But that's actually not the only reasons why different customers want to move to streaming. So one big benefit that we've seen for a lot of our customers is cost. So as Jim mentioned in his keynote this morning, they were able to take a 640 node EC2 cluster and reduce that down dramatically, right? That reduction is enabled by the move to streaming. There's a lot of best practices that you end up doing having your environment in a streaming and more automated environment, right? You spend a lot less of your time monitoring your jobs, you spend a lot less of your time doing backfills and retries, and you can end up engineering a better system, having less technical debt, and then investing your time in better things than monitoring your brittle batch job. And finally, as Fiona mentioned, there are some processes that are really hard to turn into streaming. There are some processes that are really easy to turn into streaming. But one of the great things about Spark in general is that there's a really unified environment between doing these. And almost every single team that I work with have some sort of mixed batch streaming environment. They figure out where to start, where is the low-hanging fruit, right? Where are the areas that they can turn quickly into streaming jobs? They start there, and they end up with a journey where they start to turn these batch jobs into streaming jobs. So as I mentioned, if there's one thing that I want folks to take away from here is streaming processing can seem like a pretty daunting thing. But it's actually not so bad. And there are ways that you can take batch processes and get all of these benefits, even if you don't have those streaming requirements, and start to migrate and start to move some of your pipelines into a streaming mode. And we try to make this really easy. So our way of trying to make it much, much easier for organizations to move into streaming is with Delta. And that's what I'm going to walk through a demo with today, and you'll see this in much more depth. But basically, the concept behind Delta is that we're taking a lot of this work that you might have to create a more complex orchestration with a streaming job, and we're simplifying that away. And oh, by the way, we're also creating different sorts of functionality that you weren't able to do before. Optimize, I'm going to walk through this thing called time travel. So let me sort of show you what this looks like in code. And what I'm going to walk through today is I'm going to walk through what a developer might see, what a data engineer might see as they move from batch to streaming, and as they move from Parquet to Delta. And then I'm also going to walk through Optimize and what that looks like, as you've seen it in a bunch of different architectural diagrams, but maybe you're wondering what the actual code looks like. And then finally, I'm going to walk through time travel, right? Which is, for me, I'm a data scientist. I'm not actually a data engineer, although I've worked on some pipelines. But time travel, for me, is one of the more exciting features of Delta because it enables full reproducibility, especially in the context of MLflow, where you have all the run information. And I'm going to do this for a tiny data set. So we're not going to get the Comcast side breaking of S3 buckets that also incurs pretty big credit card bills. OK, so let's get started. Let me make this a little bit bigger. OK. So this is my tiny data set that I like to play with. So here I'm going to take batch data and conversion data. I'm going to create a super vanilla sort of data pipeline that you might see in the real world. So I have my data. It's raw data. It's in JSON. I create my data frames, load these in. These data frames have their schemas. And if I say display one of those, I can see, for instance, conversions. We have advertisers. We have IDs, we have user IDs, and importantly, we have timestamps. And we have this cool new feature inside of Databricks called tooltips. And what this feature will say is it'll start to give you, Spark is great in that it allows you to tune a lot of different things. It's also very, very challenging in that it allows you to tune many different things. And this is like, we call it our solution architect in a box. Right, where it'll pop up and it'll start to make some recommendations on how you can begin to tune these and optimize. In this case, what it's saying is I'm querying a non-Delta table, right? It has lots of small files. It's JSON, as you might expect. And if I go to pick these up, I'm going to be hitting some S3 constraints and doing a lot of opening and closing of files, and that's going to impede performance. OK. So now I'm going to do my, my lovely process here where I've loaded this stuff up. Now I'm going to convert it into Parquet. That's great. I'm also going to register these in my Metastore. I now have these as lovely usable tables for my downstream data analysts or data scientists. And finally, like, maybe I have some super complex, in this case, it's like a pretty straightforward window function, right, that I'm going to run on top of my data. This is a Scala function, and it's going to do this thing called attribution, basically trying to say, OK, well, assuming someone clicked on a website, what are the impressions associated with that click? OK, so I'm going to run this attribution thing. Great. So here I have my straightforward batch pipeline. Now, note all of this is in batch. Right, what are we doing? We're picking up some JSON data. We're transforming that JSON data. We're writing it out as Parquet. We're writing this like somewhat complex join. It's doing some shuffling in the background. If I go into the Spark UI, I'll see all the wonderful things that Spark's going to do in order to try to make this as in memory and as efficient as possible. Right? And then I have my table, right? So I can just run a simple select star here, and I can see my, my timestamp, my conversion, et cetera, et cetera. And if I scroll over here, I have my dense rank, which will tell me, which within the band for the attribution, which one it is. And all of these are 1 in this case. OK, so now I'm going to try and do something a little complicated. So bear with me here. OK. Oh, too big. So now I'm going to try and show you side by side, and this is a not something that I guess is supported by Apple, so it might be a little difficult here. Like how easy it is to take this like relatively trivial batch job and turn it into a relatively trivial streaming job. Okay, so what am I going to do here? So here I'm going to, I'm looking at my batch stuff, and I'm going to, in a pretty straightforward way, instead of doing a .read, I'm going to do a .read stream, right? Now, notice I can point this at the same directory, and when I kick this off, it's going to create a, one second. It's going to create, the pointers. It's not going to execute anything, but it's going to create the pointers to these different directories, right? And now what I'm going to do is I'm going to do a write. So let me show you what the write looked like. So before I had a write to a Parquet. And now instead of doing a regular write, I'm going to do a write stream. And there are a couple things I need to add here, right? So the first thing that I need to add is I need to add a real timestamp. So what I'm going to do is I'm going to take one of my columns and I'm going to convert this to timestamp. Then I'm going to add a watermark, right? That's going to make sure that we're only processing each one of these once. And finally, I'm going to add a checkpoint, right? So this is going to add resiliency and redundancy into our system. So when I go to execute this, now it's going to kick off a streaming job, right? It's going to start to process. Now, like, it's pretty straightforward. It's like we didn't add a huge amount of complexity. We're still dealing with single lines of code. Most of the APIs here, as built by like Reynolds, as you heard in the keynote yesterday, are meant to be super, super easy to use and used by anybody. So like and what Fiona was describing earlier, as folks are moving their pipelines from batch to streaming, these are not heavy code exercises if you know sort of the small amount of steps to do, and if you take the right jobs first. Right? If you take the simple jobs that are not complex jobs first. Now, before I had this hairy window function, and rather than doing this hairy window function, I can actually now have the flexibility to do more stateful processing. So for the more complex chunks of code that require a higher level of programming, Sometimes those things will be easily put into window functions. Sometimes they'll be more or less complicated to put into structured streaming. But what you're able to do in streaming is this arbitrary stateful processing, which is actually a more powerful way to process than just using a window function. OK. So the comparison is over. Now I can make this small, and I can start to run this in Delta. So here we go. So this looks a little bit familiar. I'm taking the stream, I'm writing it. I'm writing it just like before. I'm adding my timestamp column, I'm adding my watermark column. But now, instead of using format Parquet, I'm using format Delta. It's a one-line change. Like, it's super, super trivial. So let me kill this job I had up here. Rerun the pointer. Pick this up again. And write this inside of Delta. OK. And rather than registering the table, right, rather than registering it as a query, I'm actually going to register it as a table. Right? So that's just pointing to the different directories. And now what I'm going to have is I'm going to have all of this Delta capability that I didn't have before. So we open sourced a bunch of different Delta functionality, right? And I can start to run some queries, right? So I can just do like a simple select star. Make this a little bit smaller here. Now this is going to execute, but I can also run, say, optimize commands, right? So what was this crazy optimize thing that Fiona was talking about? Well, it's just one line of code, right, that gets executed. I'm adding in this ZIO ordering capability, which is basically an additional, it's an additional optimization on top of partitioning. So now you can partition, and you can also do Z ordering. And one of the great things about Z ordering is that we store that inside the metadata itself. So you can do Z ordering and not create a small file problem. So you can use Z ordering on higher cardinality columns. So in this case, I have this geo, this geo column here. It's different cities, right? And I can run this optimize and use geo and start to get like some of the performance enhancements out of outside of out of Delta right out of the box. Just one line of code. OK. So it's going to run. It's going to execute this. And then one of the really, really cool things that's now you can that basically now is the case for every single Delta table that gets created is you can start to see the history of these Delta tables. So what is the history of a Delta table? Well, it's any time a transaction is committed within our Delta log, it creates another version inside of that table. So for this specific table here, I can see that I've made two different transactional changes, right? So the first is I've done a table update with a streaming job, doing a write. And then the second is I've done an optimize. And if I had more writes and more changes to the table, you would see all of these as different versions inside the table. Now this in itself is like sort of interesting, but a little bit boring. But what it enables you to do is now you can run a select star as of version X or as of timestamp X. And where that becomes really, really powerful is where you start to use MLflow. Because now you can start to execute runs. Oop, I didn't add MLflow to my cluster. You guys will bear with me. But so supposing I had the library MLflow attached to my cluster, right? Now I can start to execute these MLflow runs, and I can start to log the Delta version, the version of the data, as a parameter inside of that run. And actually, I don't even need to do that because every Delta run that gets executed has a timestamp associated with it. And therefore, whenever I need to rematerialize or re-execute my Delta run, I can execute it on the data as of timestamp when it was originally run. So what that gives us the ability to do is now we have the different versions of this execution within MLflow, where we can start to see what timestamp and what version of the data was actually being executed. So anytime anything is executed inside of Databricks and inside of MLflow, you'll be able to rematerialize it and rematerialize it with that specific data set at that specific time. So this makes any run that's being done in development reproducible, which ends up being like super, super powerful if you're working with a larger data science team and if you need to understand exactly what was run at exactly what period of time. OK. So what exactly did I walk through there, just to quickly wrap up? Well, it's pretty easy to get started using structured streaming, and it's pretty easy to get started using Delta. These are one-line changes, one-line adjustments that you need to make inside of your code in order to enable all of that new functionality. This time travel and reproducibility thing is, like, to me as a data scientist, the coolest thing since sliced bread, because I have endlessly tried to recreate my models, and almost always the data itself is the problem. The data itself has changed. And as we start to put all of the different data sets into Delta within an organization, all of those tables will be able to, you'll be able to do time travel on top of all of those data, on top of all of those tables. So together, what we walk through here is figure out how to reduce the complexity of your workloads, right? How to scale up efficiently, and not focus on partitioning and like all of that low-level stuff in order to build your pipelines, but focus on these higher-level functions. Figure out how to do it like really efficiently, and streaming can be a really, really great way to do that. And don't put off streaming, right? If you haven't used structured streaming yet, and if you haven't used Delta yet, it's very, very easy to get started on those today. And figuring out what are the first workloads is like is a great way to make your data sets and your pipelines more robust. So we have a couple minutes left. That's all we had. But if you guys have any questions, feel free to ask them. Otherwise, it's the last talk of the day, which is like the end of all of talks. So thanks very much. Yeah.
I thought optimize. I heard different kind of I mean like people saying slightly different things. So I thought that you can do an optimize and not your readers are still okay. They would not be impacted. But from what you're saying, the optimize was impacting the readers.
Yeah. So we have two different functions. We have optimize. We have auto optimize.
Okay.
Right. So so make sure that you're using the right one. And part of what you saw with the describe history table is that running one of these optimize commands is actually its own transaction.
True.
So you can run an optimize command while doing reads onto the original table itself.
Okay. Yeah. So if I understood right, so you can actually read while the optimize is going on, right?
Yeah.
Okay. One other thing was like when you talk about time travel, that's great. You can have a lot of data. I mean, you can go to big versions, but wouldn't that increase your lot of all your historical data, multiple versions? How do you control that?
It's like a really interesting implementation. So it actually, like, it doesn't increase the data as much as you think. It actually increases the data in constant time, or in constant state, rather than like doing different snapshots. So you don't increase the way that we've implemented time travel and in general our commit log is basically will manage those things in addition to the Parquet data itself. So it doesn't increase the amount. I mean, it will increase the amount of data inside of your system, but not as much as taking snapshots.
Yeah, it's not like multiple times, but version. Okay, thank you.
I have a question. Yeah, we are on Google Cloud. So if we need to use the Delta, like should we configure GCS? So this Delta is actually
Delta's open source.
Yeah.
You can run it wherever you want.
Okay. So what is the backend to Delta? Like some file system, right? So we have to use, in AWS you use S3. So do we need to use GCS as a backend to the Delta?
I mean, so basically, it's an open source package, right? So you just need to go to delta.io, right? And you can do pip install delta, and go on or it's not a pip install, I don't think. You'll download a jar, but it's very easy to execute inside of your workflow.
Okay, it's in memory or like, so where the storage actually goes, like when we save the data to Delta table, where exactly?
Most of the Delta functionality is not about caching. Most of it's around storing and having a transactional wrapper next to the data itself. So we can take that offline, though, and I can go into a little bit more detail here because it is a little bit complex and more time than we have.
Thanks for y'all's talk. It was a great talk. Quick question, though, about the Delta file. Whenever you're streaming into it and you end up having the commit log have tons and tons and tons and tons of modifications while you're also trying to do your optimize and periodic vacuuming to go ahead and get compaction, while still maintaining that time travel capability. At some point, you've got to age out some of those older commits. With streaming, do you find that your commit log has to be truncated more often, or?
We do that, yes. But we try to clean, because of the complexity and the stages that we have, we do try to manage to clean it up. And from time to time, we realize that there's no need for us to go back to say, like a transaction maybe a month ago, or even 2 weeks ago, since things move so fast. But yes, we do have to do that.
Okay, thanks.
Thanks for a great talk. I have a question about the sessionizing. At which point do you do it? During the streaming or after?
So the core of the sessionizing logic right now is living in the batch process that we still keep because we have to do a lot of relationship building between logs based on time. But we do have an interest in trying to move it into structured streaming again, just because we see the benefit of moving most of our batch process into streaming.
Great, thank you.
You have to go to a microphone.
Yes.
On the initial ingestion of the data, is it a streaming process, and is it writing directly into Delta from it?
So that is a streaming process. I think it works. This model works for a lot of company of scale, especially for data engineers who don't own where the data is coming in from. The good thing about streaming is you can read stream from Kafka, or like a natural streaming process, or you can read it from S3.
And is that process auto-optimizing, and with auto-optimization, do you ever run optimize again?
We actually do both currently. We do run auto-optimize just to enable stages downstream to run faster. But we also go back and run optimize once a day to make any backfilling or any data extractions, if we were to go back in time, more efficient.
Cool, thank you.
Optimize has, it has actually a richer set of like performance optimizations in it than pure auto-optimize. So, so running optimize, you'll actually get more benefit than just running auto-optimize.
Quick question on that time travel. Does it replace the snapshot mechanism? Like, if I'm building a snapshot every day for specific.
So if you're building a snapshot every day, yes, it will. You can just use timestamps for that. Generally, like our recommendation is you should keep about 3 months worth. 3 months is like a good amount of, and it depends on data size and a whole bunch of other stuff, right? But that's a good amount of time to actually run this time travel on top of. And for things that are older than that, you need a more complex archiving. And that's actually functionality that we're going to be building out, is like a more seamless interface between the snapshotting that you do for the older sets of data and the more recent time travel stuff.
Yeah, just to add on to Elliot's point is, with the snapshot functionality or with versioning, you can actually query as of a given time or anything after a certain time. They can pretty much replace the snapshot features that we have built in our pipeline, because then we can like bring back into a certain day and time or a particular time and day.
So unfortunately, we're over time, but I'm very like if you want to, I just want to be conscious of other people's time here.
I can also, should I take it offline now? Or?
Yeah. Just come to us offline and we'll chat about it. Okay. Awesome. Thanks, everybody.